All right, let's talk about seafood. You know, that one thing that can be so incredibly delicious or a total disaster. Today, we're going to get into the science of why it's so tender, why it's so easy to mess up, and how you can use that science to nail it every single time. So let's kick things off with a little kitchen mystery, one that I'm guessing has happened to pretty much all of us. I mean, think about it. How is it that perfectly cooked fish is just sublime? It's flaky, it's moist, but just a few seconds too long and suddenly you've got this dry, rubbery, frankly disappointing puck on your plate. What gives? Well, that's the big question we're going to answer today. And spoiler alert, it all comes down to science. Okay, but before we dive deep into the why, we kind of have to get a handle on the what. Seafood isn't just one thing, right? It's this huge, incredibly diverse category of food from the ocean, and knowing that variety is really the first step to understanding it all. First up, you've got your fin fish, and just look at the range here. On one hand, you have something like salmon. It's oily, it's rich. That fat content actually makes it a little more forgiving if you leave it on the grill for a second too long. But then you've got your super lean guys like cod and halibut. They're flaky and white and delicious, but they can go from perfect to perfectly dry in like a heartbeat. See, their structures are already giving us clues about how they're going to behave when we cook them. Next, let's talk crustaceans. You know, shrimp, lobster, crab, the good stuff. Their meat is a whole different ballgame. It's got this natural sweetness and a much firmer bite. And you know what happens when you overcook them, right? They don't just get dry, they get rubbery, like bouncing off the wall rubbery. It's a totally different kind of cooking disaster. And then there's this huge catch-all group, mollusks and cephalopods. It's wild. On one side, you have these super delicate, buttery scallops that literally cook in 60 seconds. But on the complete other end of the spectrum, you've got octopus, which has this reputation for being tough as nails if you don't treat it just right. So how can all of these things fall under the same seafood umbrella and act so incredibly different? Well, that's exactly what we're about to get into. All right, so we've met the players. Now let's finally pull back the curtain and look at the actual science that makes seafood so special and, yeah, so darn easy to ruin. Okay, here we go. This is the big aha moment. If you look at the meat structure of seafood versus a land animal, they are worlds apart. It's not even close. Think about it. A cow has to stand up all day, fighting gravity, so its muscles are long, they're tough, and they're held together with a ton of connective tissue. But a fish? It's just chilling in the water, basically weightless. It's a completely different lifestyle, leading to completely different biology. So this all boils down to three key things. 1, short muscle fibers. 2, very little connective tissue. And 3, a really high water content. Those are the three pillars, the scientific reasons that seafood is so tender right out of the gate and cooks in a flash. There's just less stuff for the heat to work through. And this really just drives that point home, right? A fish swims horizontally in a buoyant environment. It doesn't need a huge, beefy support system like a land animal. It's such a simple concept from physics, but it has this massive, massive domino effect in the kitchen. The animal's home literally decides how you're going to cook it. Okay, now let's talk numbers. Temperature. The proteins in fish start to cook, to firm up and change at a shockingly low temperature. We're talking just 40 to 50 degrees Celsius. To put that in perspective, chicken and beef don't even start thinking about cooking until they're way up at 55 or even 70 degrees. That is a gigantic difference. And that right there is why seafood is so unforgiving. The window for perfection is razor thin. We're talking about a tiny, tiny little temperature range. The line between a gorgeous, juicy piece of fish and something dry and chalky is just a few degrees. And on the stove, that can be the difference of, 30 seconds? A minute? It's crazy. Okay, this is where it gets really fun. Now that we've got the science down, we can use it like a secret weapon to nail our cooking every time. And we can also understand those weird exceptions that seem to break all the rules. Speaking of exceptions, what is the deal with octopus? It's famous for being tough, not tender. It completely blows up our low connective tissue rule. And you know what? It absolutely does. It's a fantastic exception because octopus is basically all muscle and collagen, that super tough stuff that holds bodies together. That's why it's so chewy. But the science also gives us 2, and only 2 ways around it. You've got 2 choices, 2 paths to tender octopus. Path 1, cook it crazy fast, like under 2 minutes. You sear it so quickly that the collagen doesn't even have time to clench up. Path 2, go the complete opposite direction. Cook it low and slow. for over an hour until all that tough collagen literally melts into silky, rich gelatin. Anything in that middle ground? Nope. That's the chewy, rubbery danger zone. And this is why we have all these different cooking techniques, right? It's not random. Searing gives you that amazing crust with high, dry heat. Steaming is all about being gentle, using moist heat to protect those super delicate textures. And then you have something like curing, which uses salt to chemically cook the fish with zero heat. Every single one of these methods is tailor-made to work with the delicate science of seafood, not fight against it. So, you know that perfect golden brown, delicious crust you get on a seared scallop? That's a little bit of delicious chemistry called the Maillard reaction. In just a few seconds, you're creating hundreds of new savory flavor compounds right on the surface. It's the ultimate magic trick. Get all that flavor on the outside while keeping the inside perfectly tender and just barely cooked. It's literally the best tasting science experiment you can do. Okay, let's bring it all home. We're going to take everything we just learned and boil it down to a super simple, super powerful framework you can take with you to the kitchen. It really all comes down to these three things. Just lock these in your brain. 1, short muscle fibers. That means it's going to cook fast and flake easily. 2, low connective tissue. That means it's already tender, so don't fight it. And 3, it cooks at a much lower temperature. The sweet spot is tiny. If you can just remember those 3 rules, you'll have the right instinct for cooking anything from a super delicate piece of flounder to a big meaty tuna steak. The science is always the same. And hey, here's one last little pro tip for you. Since seafood is so delicate, freshness is everything. And I mean everything. You know that fishy smell? That's not what fresh fish smells like. That's actually a chemical signal that it's starting to go bad. The freshest seafood should smell clean, like a day at the beach, like the ocean itself. Trust your nose. It's nature's way of telling you you've got the good stuff. So there you have it. The seafood enigma solved. It's not some kind of kitchen magic. It's just science. And once you know the science, it takes seafood from being this scary, intimidating thing to something you can totally master. So now that you've got the knowledge, the only real question is, what are you going to cook first? Maybe some perfectly seared scallops? A beautiful piece of flaky cod? Go for it. The ocean, as they say, is your oyster.